Good day everyone. We're going to tackle about sedimentary rocks. What is sediment? Sediments are loose materials such as rock, fragments, mineral grains, and bits of shell that have been moved by wind, water, ice, or gravity. Sediments come from already existing rocks that are weathered and eroded. Sedimentary rocks forms when sediments are pressed and cemented together or when minerals form from solutions. How are sedimentary rocks formed? Sedimentary rocks forms when sediments are combined to form solid rock. Lithification is the fancy name for forming rocks. Sedimentary rock is formed in two ways. First is compaction. Compaction is formed by pressure compacting sediments together. It is the most effective in the clay sediments. As the sediments accumulate increasing thickness, the upper bed presses more and more heavily on the under them. In clays, this sedimentary loading causes the grains to become crowded together and the water in the pores to be squeezed out. The clay becomes a shale. Second is cementation. Cementation is the form pressure forces water out of the sediments. The dissolved mineral crystallize, cementing the sediments together. The most common cement are calcite, silica in the form of quartz or chalcedony, and iron oxide. These cements have been deposited concurrently with the crystallization of any colloids that were disseminated through the sediments, or they may have been both and later either from the adjacent body of sediment or from afar by groundwater moving through the pore spaces. Importance of sedimentary rocks. Rocks form from previously existing rocks of fragments of once living organisms. They form as a result of deposit accumulating on Earth's surface. The most conspicuous feature of sedimentary rocks is their layered and stratified structure. They are also great practical interest because they contain coal, oil, and gas, and many other mineral supplies, notably the sedimentary iron ores, the most valuable of the metallic mineral resources. Given more important to the science of geology, they contain most of the evidence from which the geologic history of the earth is determined.
Types of sedimentary rocks. We have detrital, chemical, and organic rocks. In detrital, we have the conglomerates, breccia, sandstone, and shale. The first one is the conglomerate. It is a lithified gravel. The fragments cemented to form a conglomerate is arranged from pebbles a fraction of an inch to boulders many feet in diameter. They may be closely crowded together with a little matrix, or mingled with any proportion of matrix. If the pebbles are sparse, the rock is termed a conglomerate sandstone. If the digital fragments are angular instead of rounded, as in a conglomerate, the rock is termed as breccia. And if the breccia was laid down as a far deposit, the lithified equivalent is called conglomerate. The next one is the sandstones. Sandstones are composed of cemented sand grains consisting of quartz. However, transitional varieties that grade into other sedimentary rocks. Sandstones are porous, and the aggregate volume of all the pores in a sandstone range up to 30% of the total volume of the rock. The pores are generally large enough to allow liquids to move freely through them, and therefore the sandstones are permeable. And because of this extremely important property, sandstones are by far the most common reservoirs for petroleum and artesian water. Schist is a special variety of sandstones containing so much feldspar that it resembles a granite in appearance. It is more commonly of terrestrial than of marine origin, and its formation is favored by the mechanical disintegration of granitic rocks in various climates, either cold or arid, where chemical weathering is feeble. The next one is a sandstone. Schist is a special variety. And then the shale. Shale is consolidated clay and has a characteristic flat conchoidal or shelly fracture, as the etymology of the term implies, from the German scale, a scale, shale, hacks or slice. And in chemical and organic rocks, we have the evaporated rocks, which is formed due to evaporation of saline water. For example, gypsum is a naturally occurring stone, a metallic salt of calcium. It commonly forms as an evaporate from the dissolution of limestone by exposure to sulfuric acid from volcanic activity. And then the carbonate rocks. It is basically from the carbon calcite, both by chemical leaching and by organic source. For example, limestone. These are composed of calcium carbonate. Lastly is the organic rocks. From due to decomposition of organic remains under temperature and pressure. Coal is classified as an organic sedimentary rock because coal is made up of decomposed plants which are organic.
Texture of sedimentary rocks. First, origin of grains, either clastic or non-clastic. Second, size of grains. Coarse grain greater than 5 mm, medium grain in size 1 to 5 mm, fine grain less than 1 mm. Third, shape of grains. Angular, subangular, rounded, subrounded. Sphericity and roundness of sediments or grains indicated varying degree of abrasion and transport. Example, breccias, angular and rough, conglomerates, rounded gravels. Packing of sediments are grades, open packed or densely packed, related to stratigraphic pressure. Lastly, fabric of grains, sedimentary rocks containing elongated particles under orientation demarks the flows of sediments. Example, rhyolites, high degree of crystallization, and parallel access of grains. Classification of sedimentary rocks in clastic sediments. First, rhodaceous rocks. Rhodaceous rocks are those rocks which one made of particles having grain size more than 2 mm in diameter. Example of rhodaceous rocks are breccia and conglomerate. Second, arenaceous rocks. Arenaceous rocks are those rocks which are made up of particles that having the grain size in between 1/10 to 2 mm diameter. Sample of arenaceous rocks is sandstone. And lastly, the argillaceous rocks. Argillaceous rocks are those rocks which are made up of finest clay particles. Size of particles is less than 1 over 10 mm in diameter. Sample of argillaceous rocks is shale. Non-clastic sediments, chemically formed rocks, originally formed rocks. Example are carbonate rocks, salt rocks, ferruginous rocks, siliceous rocks. Carbonate rocks. The most abundant carbonate rocks are limestone and dolomite, which are formed by chemical precipitation of calcium carbonate from seawater. Salt rocks is the name of a sedimentary that consists almost entirely of halite, a mineral composed of sodium chloride. It forms where large volumes of seawater or salty lake water evaporate from arid climate basin where there is a replenishing flow of salt water and a restricted input of other water. Ferruginous sandstone has either gradual contact or sharp or source contact with the underlying lithophases, which is commonly bioturbated quartz arenite. The composition of those ironstones are limonite and pyrite. The origin of the ferruginous layers can has been previously attributed to be diagenite. Siliceous rocks are sedimentary rocks that consist of silicon oxide either in the form of amorphous silica or microcrystalline cryptocrystalline quartz or chalcedony. Particle size in sediments, P-ball, 10 mm and above, a conglomerate. Gravel, 2 mm to 10 mm, also a conglomerate. Sand, 0.1 mm to 2 mm, a sandstone. Slate, 0.01 to 1 mm, a slate stone. Clay, less than 0.01, a shale. Structures of sedimentary rocks. Stratification, lamination, cross bedding or current bedding, graded bedding, ripple marks, concatenary structure, minor structure. Structures of sedimentary rocks. First, stratification. The deposition of the sediments into the layer or beds are called stratification. The plane dividing different beds are called bedding planes. Bedding is most important feature of a sed. Rock beds are usually less than 1 centimeter. Laminae is greater than 1 centimeter. Orientation of bedding helps in knowing the paleocurrent direction of all rivers. Second, lamination. The thin bedding less than 1 centimeter in thickness are called lamination. Lamination is found in every fine grained rocks. It is observed in the picture. Third, cross bedding or current bedding. In this structure, minor beds or laminations lie to an angle to the planes of the general stratification. Current bedding is commonly found in shallow water and wind-formed deposits. This structure shows rapid change in the velocity and direction of flow of streams or when carrying sediments. Fourth, graded bedding. In graded bedding, each bed shows a gradation in grain size from coarse below to fine above. This results by rapid sedimentation and water. Fifth, ripple marks. The surface of some sedimentary deposits shows undulation or ripple marks. These are produced by the action of waves and current in shallow water as well as on the surface due to wind action. Lastly, minor structures. Some bearing planes shows minor structures such as mud crack, rain prints, footprints, snake prints. These are found in the fine-grained sedimentary rocks.